Hey guys, today we are going to learn about trustless data sharing within Excel, right? I know there's a way to password protect files, there's a way to hide the formulas, there's a way to lock the file so that no one can mess around with it. But what if you're in a situation where you need to share the file, the entire data, but you don't want to reveal the information, right? So, for example, you could have sensitive customer information like this, where you have the name and personal details of the person, but you would not want to share this with others. Of course, this is a sample data, but uh, what you can't be so careless with your real world data, correct? So what you would want to do is somehow mask out the information by leaving the data as it is. No need to lock the file, no need to password protect it. You can just blindly share it with people and still be safe enough, be worried, be stress free enough to know that your information is safe, even though you shared the Excel file out. So it's a very simple process for that. To understand how that works, let's look at a very simple thing called hashing. So this thing, it could be called data masking, it could be called redacting, it could be called hashing. So there's many different ways. Let's look at hashing. Um, you basically have an input, your plain text message. You give it off to a function that hashes it, right? And you get some gibberish value out of it like this. Okay. So that's basically what hashing is. Okay. Now just imagine every data point you have here in Excel, you could essentially just change it to this gibberish thing and still have the data in somewhere, but not really. Uh, you can have that this whole file of gibberish and then share it very safely with everyone without them knowing what to do, right, with that data, without them accessing the phone numbers of people or whatever, right? So let's look at this. Now hashing, I'm using it as an example just so you know how it works. uh, but For example, if I just paste this hash that I've created in here, because I've done it on a very common format, right? It's called base 64, a very common function of hashing. Anyone can actually go ahead and decrypt this or decode this using whatever encoding we've used, right? So now, if you want to know what the data is behind this, you will have to put it in a decoder, a base 64 decoder, and only when you press decode, you'll get the original text back, right? So I had just written this is a secret and encoded it using base 64 ASCII UTF-8, and that's the output I got, which I just now pasted here, and just to demonstrate how this thing could look. Okay, so your actual information is this, but your data will just show this, correct? Now, this is a ready-made function that I've used just to showcase how this works. But what we are going to do is something more like this, right? Where we're going to map by ourselves. We're not going to use a ready-made hash function. It has other use cases, but we want to safeguard our own data, correct? So to do that, we will do this kind of mapping on our own. Okay. The only thing is never ever lose the map. Okay. There's no forgot password button here. There's no possibility to retrieve this unless you have this key of what you've converted to what, correct? uh, so let's look at a very simple example, right? Now this customer's name is Puneet Makar, right? uh, Now if I want to hide his data, right, I could basically change EE to something else, let's say 33, or A to, I'm doing very obvious ones, at the rate symbols. And now it's starting to look a little different, a little more unrecognizable. If I go further, and let's say I don't take very obvious ones, but I decide that every time there's an A, I will replace it uh, with a percent symbol, right? Every time there's an A, I'll replace it with a percent symbol. Now, this is the key you have to write somewhere. Basically, A is percentage, right? Now, wherever, and obviously don't ever share this key with anyone, because they will be able to decrypt your data very easily. So now I've done this on one single cell, but let's say I had to do it for everything. Okay, so let's just continue with this one cell. Um, then we have P. Let's just take the names P, U, N, E, E, T, right? Let's just take the first one. So now then I can decide the P is, I can use a close bracket, U I can use an open bracket, N I can use AND, for E I can use V, and let's take R for T. Okay. So now I know wherever I find a P according to this, right? Wherever I find a P, I have to basically change it to a close bracket. U will be your open bracket, N will be your and so on and so forth, right? E will be VV, okay, and T will be R. So, do you see how this becomes very unreadable unless you know the key, unless you know the mapping, right? There's just one issue with this. If you're sharp, you would have noticed this, that if there's an R already, like in Makar, the R here and the R that we replaced are now both the same. So when we go to decode this, how do we decide which one is the R and which one is supposed to be the T, right? So you just have to be careful never to replace things that are already there in your data, okay? Only if you're sure these symbols are not there in your data, you can go ahead and make the changes, okay? So to start with symbols is a good idea, and what you could do is, you don't even need to do it for every single alphabet, every single thing. You can just do it to the extent that you're comfortable with. So I'll just undo a couple of times, and I'll just put his proper name as it was. And you see I did this in a very manual fashion right now. But let's say I want to do it for the entire list of names here. Okay, so what you can do is you can select this column and you can press Ctrl H, or you can go to the home tab and say replace. Okay, so in this find and replace box is make sure you make the selection first. If you want to select, make sure you make the selection first to limit your replacements to only that column. Now I can find A and replace it with percentage anywhere, right? I'll just say replace all, and you'll see it's replaced 2719. It's made 2719 replacements. Again, instead of P, I'll put a close bracket. Okay, I'll say replace all. Okay, again, I'll say U. Okay, and I'll say open bracket. I'll say replace all. Okay. Then again, I'll say E, and I'll say, sorry, N. I'll say replace this with AND. Okay. And again, I'll say E, replace with V, replace all. Again, this would be a little bad to do, the V and R, because you don't know what is to be replaced back. I'm just doing it here on purpose so that you know what the risks are with this also. Okay, replace all. There you go. Now, as you can see, this whole column is more or less unrecognizable, and if you do it for like if you look at this VV and KRRR, like it's completely unrecognizable. Okay, now of course I've used two mistakes here on purpose, so you can see how it could go wrong, just to make sure you avoid that. But for the rest of it, you'll see it'll work perfectly, right? So if I go ahead and make these changes, Okay, so now I'm free to share this file with everyone, anyone and everyone. They can continue working on the data. Maybe if they have layout changes, maybe they have something else to do with this, maybe they have to take a count or do whatever they have to do. They can do that without you revealing the customer's names, right? Similar things can be done for the number, location, and so on and so forth. But do you understand that even if you partially block most of the data, right, there's no way this becomes usable to anyone, right? What they will have to do, the only other possibility for them is to go and try to decrypt it. So, for example, do you know every single password on the world is crackable, right? The only thing is, see, if you read this, it says every password you use can be thought of as a needle in a haystack. Um, Ultimately, trying every possible combination of letters, numbers, and symbols until you get the password, it's basically discovered. The only question is, uh, will it be too soon or enough later? That's a good way this website has put it, and they have a really good uh, uh, thing here. If you put 1 2 3 4 5 6, you will see it will take just a few seconds for or minutes for someone to try and figure this password out. But the more combinations you have, like uppercase, lowercase, digits, symbols, all of that, and the number of characters, all of these combine to make it a little more difficult to crack. Okay, so in essence, if you look at it, every piece of information you have, we are converting it into a password essentially, right? So for example, if I just take this one and paste it here, you'll see this would take 2.3 billion centuries or trillion centuries to, you know, guess and go through every single combination and arrive at this. Uh, of course, there's few other nuances to it. Like for example, if I take a very very small one, like a shorter one, the shorter it is, the easier it will be. But again, this is just because we've not actually done the replacement for everything. It's just 3 characters literally, correct? And this is also making my case stronger for putting symbols in, right? So putting symbols, making it not case sensitive, correct? All of this. So, like for example, in this, if I just add a number here instead of O, it'll be 0. You'll see it'll take that much longer. And there's something called as padding where you can add more data in. So for example, if you know like all your O's you want to convert into something, you can convert it into 3 dots probably, right? I mean 3 O's, or 3 O's inside a bracket, for example, right? So now I know, okay, whenever I have to kind of replace a O anywhere, it's with brackets and 3 zeros. Okay, so as you can see, it's very readable for you at least. Okay, but still, this will take 1.65 hundred centuries in like the quickest possible way, right? Which is assuming 100 trillion guesses per second. Even then, it will take these many centuries to crack this. Okay, so you can be rest assured, unless we get quantum computers as commonly as personal computers, your data is safe like this. Okay, quantum computers might probably take um, um, a few more seconds than this. Yeah, but that's a long way off. But till now, you see your data is safe. So, for example, instead of just replacing it with one character, okay, I could replace all O's, like I said, with bracket, sorry, all O's with a bracket, 000 bracket. And this makes it, oops, this was Excel's problem. So you can basically just convert every O you find into this code, right? And this makes it infinitely stronger, right? So this is how you can apply hashing and into your own data to mask only the information, right, from your Excel file. And like you can see, just imagine I do this for numbers, right? So let's say every time there's a 9 in the data, I want to write NINE. Obviously, this is a stupid thing to do, but if I just make this replacement over here, so let's just select this column, Control H, 9 will be replaced by NINE. I'll say replace all, and so many replacements were made, and you see already this data is becoming a little more unrecognizable. Let's take one more number. Let's take 1 this time and change it to, now I'll do a smarter thing. I'll change it to and. Okay. It's not necessary to use the same thing, so I can use um, and square bracket and square bracket. Oops. Yeah. So now, wherever I search for 1, right, I can replace this with this combination of keys, right? I'll say replace all, and it's done. Close. And you have to just make sure that this combination is completely unique vis-a-vis something else. And yeah, there you go. Now if I want to decrypt this data, this list of numbers, like you can see, it's already very confusing to read, right? We can just tell the person who's to work on this data, okay, anywhere you find this kind of data where it says phone, mobile phone, whatever, it's all supposed to be in one column called phone. It's all supposed to be phone number data. I can't reveal the numbers to you, so I've kind of encrypted them and given it to you. Okay. Uh, that's all. That's all. So now, when I get the file back, when he's processed it, done whatever he has to, when I get the file back, I can simply go back and decrypt this. So this time I'll put this code here and 1 over here, and I'll say replace all, and it says 981 replacements made, and I can go back and change the 9 to 9, and I'll say replace all, and you will see I have my proper original data back as it was. Okay, so agreed, this takes a little bit of time to implement, to do it properly, but if you are really concerned about the information that your Excel file holds, it's best to do this. Okay, and wherever you do write the mapping, either keep it in a physical location somewhere or keep it in a different computer altogether or a different network altogether, so there's no chance of anyone finding it. Just make sure there's no way you lose this. Okay, uh, there is no alternative to that. To, however, safeguard yourself, okay, what you can do is make a copy of your file, right? So let's imagine I had all this data perfectly as it is in its original form somewhere. Then I don't really need to worry about the file that I'm sharing outside, right? I can encrypt it however I want and then share it out. That way, what happens is when I do decrypt it, I can also do random checks and figure out whether the decryption has happened properly, right? And if you just take care of a few things, you will be able to encrypt your files properly on a cell by cell level in a way that the data is still as it is almost, but your information is not revealed to the other party, right? So this is a very interesting, very simple, very powerful use case, which you should try. Just a couple of concerns before we move on. Uh, do not use star or a question mark to replace. Do not use these two as characters, or a tilde, for example, right? Do not use these three at all. Uh, why? Simply because they are called as um they're called as wildcard characters in Excel, right? So, for example, I have C and I have a bunch of numbers here, right? So, for example, uh, if I wanted to replace the first letter after C, okay, I can go to C, find and replace, and C question mark, for example. So it will search for C followed by any one character, and I can replace it with C with another character. So you will see whether it's C8, C4, C9, C8, C7, it will all be replaced by C2. Okay, that's what a wildcard character does. Now the question mark is for a single character. So if I replace it, you'll see instead of searching for C8, C9, C7, C4 separately, I just told it, okay, whatever the character is after C, replace it with a 2, right? So this is a little dangerous to do. And similarly, if I replace the question mark with a star, it means any number of characters, right? So for example, you have C82, the 82 will be replaced by a 2, okay? If you have C433, it will also be replaced by C2, okay? In this case, I'll just give a quick example. Instead of C, I'll write D, and I'll do it once more over here. And you'll see, because they don't start with a C followed by whatever number of characters or digits, it will not replace these two. So if I say replace all in this case, you'll see wherever it's found anything that starts with a C, okay, it replaces to C2. So just to illustrate how dangerous this is, do you see Chennai everywhere has become C2 because it starts with C and ends with anything. So Chennai is like basically HANNI is here, right? So just please avoid these two things, these three things, and you should be good to go, right? So again, to reiterate, it's the star, the question mark, and the tilde, right? The tilde is the key right next to your one number on the keypad and above tab. Yeah. This is an escape character. It should not be an issue, but better not touch wildcards at all, right? Okay. Another thing is the sequence of changing, right? So let's say I want to decrypt this again. Okay, I'll just leave these as it is. Now I'll go back here and I'll go back to Control H, and I will say let us get our A's back. So all the percentages will become A. I'll say replace all. I've got some of it properly back. Then all my close brackets are actually P. I'll say replace all. I'll get it back. Now if I choose open bracket, I'll say this is U. I'll say replace all, and that's the number of replacements is done. I'll say N and replace and replace with N. So now I'm basically going in the reverse direction. I'm searching for these and replacing with these. I say replace all, and that's the number of replacements. Then I'll go to, so now this is where it's going to become a problem, right? So wherever it finds a V now, it's all going to convert that to E. Okay. So if you notice, like over here, we had Puneet, right? Now this will convert properly, but something like Manav, right, will become Mane. Sorry, that was already Mane. But if you go to something like DVOL, right, this is supposed to convert to DEOL. But if you look at something which starts with like for example Avinash, the V is supposed to be here, right? Now what will happen is it will become AEINASH, right? This is again why I'm demonstrating you should not use other letters in place of other letters, right? So let's just go through it and replace it anyways. I know the E and the T will be a problem. So all the V's are actually E's. I'll say replace all, and all the R's are actually T's. I'll say replace all, and yeah, that's it. There was no O, I guess, but we'll see if we fall into something. Now you'll see most of the names are right. Just to show you how uh, unique this is. If you just go to Avinash, you'll see some of the names will look really off this time. Like this was Rajani Gurdas. Rajni Gurdas. This has become T because we overwrote R with T, right? So don't do this kind of stuff because your data will become this unrecognizable. Like the there's no way you can figure out what the original name was unless you know it or you can guess it. So yeah, this is all the risks involved with it. But I think if you are ever in a situation where you really don't, you have to share your data, but you don't want to share the information, this is the way to go, right? Again, do not lose your mapping. That is your key, your password to your own information. Okay. So yeah, I hope this helped. Um, by the way, fun fact before we leave, you can also use the base 64 to encode and decode any of these formats into a random string. So sometimes you might want to send across a file, but your platform allows only text. You can convert that file into a base 64, like a long string text, and then you can use decoders to put that base 64 code here and get your file back. So have fun. Thank you so much. Hope this helped. Bye.